In this video, we're going to be destroying a wood pillar like this. Hey everybody, my name is Bryan. Welcome back to my channel. I'm doing this video as an aside to the current fracture series that I'm doing on YouTube. This is because this is going to be a little bit more of an advanced walkthrough, and I wanted to showcase how you can destroy a wood pillar and get a pretty decent look. We're going to take this all the way through Karma and actually render this out. So without any further ado, let's dive right in. All right, I'm gonna go ahead and disable this real quick. I had some cameras and lights that I deleted as well. I also went in and made sure that I have a fresh slate in LOPS, and I'll explore what that looks like here in a few. But to get started, I'm just gonna go ahead and go with a geometry node. Let's go ahead and call this Wood Fracture Tutorial. And I'm gonna dive in. Let's go ahead and start with a box. Now this box, I'm gonna make it 3 meters tall, and just about a quarter meter in the X and Z axis. And then I want to pin this to the origin on the Y axis. To do that, I'm going to use a match size, justify Y, we'll switch this to min, and I'll just do min there as well too, doesn't really matter. What we'll do at this point is we'll prepare this for fractures. So let's come down here and use the RBD material fracture. And before I click on it, let's go ahead and switch this to wood, and then let's go ahead and click on it. That way it just solves all at once and I don't have to worry about it. I'm going to reset my simulation here. Cool. So by default, this is what it looks like. We're going to play with some of the settings here. Now, what I like to do at this point is I like to actually add in an exploded view. Now, I know there's an RBD exploded view, but I actually like using 2 exploded views here so that I can actually look at both the low res and the high res separately. So here's the high res and here's the low res, and they're gonna look the same right now because we haven't really dialed in any settings yet. But let's go ahead and take a look at this RBD material fracture node and see what we can get. I'm not really gonna touch too much here, but I do wanna play with the noise a little bit. I'm gonna come down here and say 0.53 on the height, and let's say 0.119 on the element size. I'm gonna bring that down a little bit. And immediately we're gonna start getting a different look here. And that looks pretty good. Let's go look at the cut. Now on the cut, there's a few parameters I want to change here actually. So on the curve noise, I want to come down a little bit to 0.9. And on the element size, I actually want to come down to, let's say, 1.5. Again, we're looking at the proxy right now, but nothing is really changing yet. Where it's going to change is going to change right here in the detail attribute. And so what we could do is use convex decomposition, and immediately you'll see that in proxy geometry that it's going to actually change. And for this simulation, this will be fine. I'm going to hit my increase weights as well. We're not going to change any of these at all. Now under the cluster, we're going to actually change quite a few parameters, and this is where we're actually going to get that look. Before I forget, let's come back to the cut, and I want to increase my splinter density to, let's say, 50, and I want to lower the splinter length down to, let's say, 0.5. And then let's go to the cluster and let's go ahead and hit random detach. I ain't gonna touch too much of the settings here, but the big one that I actually wanna change is gonna be right here where it says combine pieces. I'm gonna switch this to group constraints. And this is because I'm gonna be modifying this down the line. This is how we're gonna actually get the look that I have. If you don't flip this, you're never really gonna be able to break these chunks using your glue constraints. And by the way, if you wanna see the difference now, if you take a look, because of that proxy setting that we set, here is what it looks like without proxy. And here's what it looks like with proxy. One thing I want to change here, I'm going to go and flip this to manual so there's an update. I'm going to increase my jitter here, 0.2. So 0.2, and then I'll just hit auto update here. And this is kind of what I ended up with. Play with the settings as you see fit. The jitter here actually got me the look that I was looking for. And I decided to stick with this. So again, these are just settings that I did after a little bit of R&D. I didn't really change too much actually, but this is what I ended up with. But now at this point, let's go ahead and configure this for fracture. Let's go ahead and type in an RBD configure. Now I do this a little bit unique. I actually use 2 RBD configure nodes. I do a set active group, and actually we'll do another RBD configure here. And let's go ahead and wire that in. And this one is going to be my set inactive group. So we'll do set inactive. On this first one here, what I'm going to do is I'm not going to change too many settings here. I'm just going to turn on my active where it says 1. And on the bottom one here, I'm going to add that active group here. And what I'm going to do now is I'm going to create my own group by hitting the arrow key here and then just highlighting, and that's too much. Let's do, yeah, that's fine, I guess. No, maybe a little bit lower. We'll start with this. I'll just hit enter. And then under the active, we'll turn that on and I'll hit 0. And this just gives me the ability to art direct as I see fit. I can come in and add more into my active group. You can definitely do this in just one node, but I feel like this gives me the most control. All right, the next thing I want to do is I want to do an RBD constraint properties. Now I actually won't touch this too much yet, and sometimes I actually deactivate this in my simulations. But at this point, I'm ready to go. And yes, I could use the RBD bullet solver here at the SOP level, but my workflow is a little bit different for optimization, which allows me to come in and really drive settings up on the fly when I want to. And I'm going to create a outwood high res. Let's do another null. We'll do outwood low res. And let's do one more null here. And let's do an wood constraint. And then what I'm going to do here now is I'm going to create a sphere, because we're going to need an object that's going to shatter this wood. And I'll just go ahead and template this for right now. Let's go ahead and move this to 0.33. Let's move this up 1.5, and I'll go -5 in Z space. Let's go ahead and create an attribute wrangle, because we have to give this a attribute here with the velocity. So we'll do at v equals channel v. We'll call this vel direction. And then I'll do another at v here, multiplied. So asterisk equals channel v, or channel float rather, vel multi. And let's go and promote these two parameters up. And this is just the way that I do velocity. So now I can do, let's say, 1 here, and then I can multiply that by 33. That way I can multiply all 3 of these by whatever direction that I want. And then I'm going to go ahead and pack this. So let's pack this object. It's important that we come down here and move all these attributes forward. And then I will do a null. And we'll call this out projectile. And let's go ahead and create a dot network now. And in this dot network, let's dive in. Let's go ahead and set up our sim. So we'll start with a rigid body solver. I'll start with a merge. Let's start with the ground plane. Tie these in like so. Let's start with the gravity. Let's go and lay this out. And then what I'm going to do here is an RBD packed object. Do another RBD packed object. A merge. And before I forget, let's just go ahead and start with a constraint network and a glue constraint relationship. And this will be our basic network for a sim. We may make some changes down the line. I may add in some resistance, but this is where we'll start. So let's go and start importing our asset. So first things first, I'm going to come in here and I'm going to grab the outwood low res. We're going to be simming the low res here. This is just going to make our lives so much easier down the line. RBD packed object here. Let's go ahead and grab in the projectile. Out projectile, accept. Let's go ahead and inherit the velocity point attribute. And then down here, let's go ahead and add in my constraints. So outwood constraint, accept. And at this point, we should be able to just simulate, and nothing's going to happen because the glue is rock solid. So I'm just going to lower this all the way down to 1 since I have a glue parameter outside, and we're still not getting much. So let's go ahead and just disable this for right now and see what we get. Still not a whole lot happening. Let's see why. I believe it's because I need to actually come in here and give this a little bit more density. I'm going to give that a little bit more density, or a lot more density. Still not a lot happening. Let's see here. Let's do 0.1. And there we go. Now we're starting to get some action happening. And a lot of this is just due in part because substeps as well. So let's go ahead and play with the substeps. Let's just increase this to 20. And I'm going to increase my constraint iterations to 20 for now. Okay, and then let's go up. I'm gonna increase the substeps here to 3 and see what we get. You'll see that it's rendering really slow. I think the substeps are too high. Let's actually lower this down a little bit. I'm actually gonna increase my velocity here. It's already to 33. Let's say 35, just a little bit. Let's see what it does. There we go. You'll see it's actually going a little slow because I've increased my substeps and my iterations, but we'll leave those there. That looks pretty good. Maybe we'll play with the glue a little bit. So if I come up here and we'll say 0.05. Now, part of the problem with this is a lot of the objects are just going to fly off into space right now. And what I want to do is I want to keep that from happening. And so what I can do is wire in a pop wind. Now, I could do this with a pop wind, and we can also do this with a pop drag. Both of these will work. In fact, we'll try the pop drag first and see if there's any difference for this one. I'll just drag the pop drag, and we'll leave the air resistance at 1. It may be a little too extreme for my object. Yeah, it's too extreme for the object. So I usually lower this to, let's say, 0.1. And the object should no longer fly too far away. Okay, let's increase this to, let's say, 0.25. That looks already way better. Kind of have this explosion effect happening. Cool, this looks good. So what I'm gonna do at this point is I'm gonna cache this. So we'll come down to the output node. I'm only at 72 frames here, and I'm just gonna save this to disk, and then we'll come back and we'll pick this up. Okay, we're back. The cache is finished. So I am going to come over here and just playback simulation. And this will go way faster, and take a look at that. This looks pretty good. We have a few issues happening. These objects should stop. In a later video, we'll go through the art direction on how to actually get that. That's not the purpose of this video. This is the introduction to just wood fracturing. So what I want to do at this point is, since we have this .NET simulation, we're actually not going to use this at all. I'm going to come over here to the object merge now. And at this point, what I'm going to do is I'm going to delete the asterisk, and I'm just going to come over here and do RBD packed object 1. This will be easier if I actually named it, but I just know that it's RBD packed object 1. And that's because I only want this simulated. I don't want the cannon. I don't want anything else out. And what I'm going to do is I'm going to come over here now with my outwood high res. We are going to do a transform pieces. Take this low resolution simulation, which you can see that actually still took a while to cache. And we can actually use that to drive the high res now. And if I take a look at this, you'll see that the high res now being simulated. And this is a huge time saver that I use in my workflow, and this is kind of the purpose behind this video, which is pretty cool. All right, so we have this simulation now. The next thing I want to do is I actually want to make sure that I set this up properly. So this is packed. So what I want to do is do an unpack. So I have all my groups here. And let's take a look at what I got. And you'll see that I have velocities now down here. This will be important when we go into Karma. A few other things I want to do before we go set this up for Karma is I want to actually come up here now and set up a few things that we're actually going to need. After the box here, I want to give this UV. We're going to do UV unwrap. I'm not going to care too much about these UVs. I ain't going to go to town on them. This is just a simple tutorial. It's not a tutorial on how to actually UV. But now that it has UVs, we should be able to come down here to the unpack. So we now have the UV'd object. So let's go to views here, and we'll look at the UV editor. You'll see that we have some crazy stuff happening here. I'm going to show you guys how to fix this, or how I fix this, so that we can actually get a better look out of substance here. once we go. But you'll see that these objects all have UVs now, and the interior does as well. However, I want the interior to look a little bit different than what the exterior looks like. And so to take that in consideration, there's a few changes I have to make. Now, one thing is if we unpack this properly, you'll notice that we come in here under the primitives, we get this grouping, we get groupings in here. And one of the ones I want to take care of is this group inside node here. If I do that, I can do a UV layout. I'm gonna hit save here so that I don't crash. And then I'm gonna move here. And then under the UV layout here, you'll see that we have an inside group. Let's click on that. Let that cook for a few minutes. And you'll take a look that I get this now. Now it is actually overlaid on top, but at least these will be a lot easier to use and get a nice clean texture. I just found this to be a really good result. But now at this point, we're ready to export this. And the way I do this is I'm just gonna throw down a blast here. And I'm gonna go ahead and create a blast with the inside. Let's go ahead and hit that, and we'll delete non-selected. So we get the inside right here, and then I'll do another blast. And under this blast, I will actually delete the inside. And what this will allow me to do now is I can do a ROP FBX output, and we'll just do 2 of them here. So for this one, I have this being saved into my wall practice file, which is just a project that I have set. So let's just go ahead and export this. We'll give this a name. We'll call this, let's do Geo. Whoops, we'll do Geo. And we'll call this wood tutorial inside.fbx. There it is, okay. And I'll just save that one to disk, shouldn't take too long. And then we'll do the same thing here. We'll do a ROP FBX output. And let's just go ahead and I'm gonna take this all here. Copy, move this here, and we'll call this outside. And I'll save this on the disk as well. And then what I want to do before I go into Substance, I want to prepare these two to be used properly. So I want to give the blasted group here its own group. So let's do a group, and we'll call this outside and merge these together. And we're pretty much back to where we were. And then we'll do a null, and we'll call this out wood fractured. And then in between the two, I actually want to cache this out. So we'll do a file cache here at this point, just to make this easier so that when we go and render, I'm not sitting here and waiting for each frame to cache out, and that would be pretty insane. So 1 to 72, we'll just go ahead and save to disk here, and then it should automatically load from disk once it's done. And so this is gonna take a while. I'm gonna go ahead and pause, and we'll pick it up from there. All right, so the cache is done. It took me about 15 minutes to cache it, just to be aware. But that is done, and so I'm just gonna go ahead and make sure that I have the null flagged here so that it's not too crazy. And then you can see post cache, this is running very fast now. So we'll come out here, and I'll just go to click off. Let's go ahead and start bringing this into Karma. So to do that, let's come up here to the stage, and I'm just gonna start with a Karma node. And in 20, this is how it looks when you get it imported in. I'm gonna just go ahead and throw in a merge because we'll need that at some point. And then let's go ahead and do a SOP import. Now under the SOP path, what I'm gonna do is I'm gonna come up here and grab the out wood fracture. Let's go ahead and just wire that in. There you go. If I just hit play, you'll see that it comes out, but no materials are in just yet, because we have to actually assign the materials. But if I come down here, I'm going to import the data here, and I want to do the subset groups, and I want to import my inside and my outside, because we'll need those here. I'm just going to go ahead and fast forward to about frame 8, just so that I can see the inside and the outside. I have my subnet groups. Let's go ahead and start creating the materials now. So to do that, I'm going to create a material library. And what we'll do now is we'll create the materials in here, but what I'm actually going to do is do an assign material node afterwards. So that we can see this in real time. I'm actually in the Karma XPU perspective right now, but to see this in real time, what I'm gonna do is I'm gonna come over to the geometry spreadsheet, and I'm going to just click and drag this over the SOP import 1 node. As I'm gonna hit a forward slash asterisk, and then I'm gonna type in the group. So this one I'm gonna do outside. I don't have materials yet, so we'll set that up here in a little bit. But then what I'm gonna do is I'm going to add another one here. So we have the outside one, and I'm just gonna copy this, paste that there, and we'll do an inside. Okay, so we have our two groups. So now let's come to the material library and let's dive in and let's do a Karma material builder. Now I'm in Houdini 20, so this process has actually been refined a little bit. So for this first one, I'm gonna do a wood out, and then I'm gonna do another Karma material builder, and this one will be wood in. So let's go up now, and under the assigned material, under the material path, I should be able to come down here, go to materials, and since we are on the inside one, go to materials and you'll see wood in, we'll hit apply, or okay, sorry, it bugs out a little bit, and I'll just copy this down there, and this one will be wood out. Cool, so we have our two applied right now. If I come down here and let's just view the Karma render settings, there you go, take a look at that. So there they are in my tree graph. Now I can start building these materials. So let's go into the material library. We'll do the wood out. Now I've already went in and created all the textures and substance. This isn't a substance tutorial, so I'm gonna do an image file here. So a material X image. And let's come over here and grab the out. So I'm in the texture wood out, base color, accept. And I'll just take this into the base color right here. You'll see that it immediately applies. Let's go ahead and grab in, we'll call this out color. Let's do another image file here. We'll call this out rough, and then I will grab my roughness. Well, I need to switch this file color space here to raw, and I'm gonna go into my specular, and we'll go into specular roughness. Let's do another one, image, out, and this one I want to go into my geometry. Let's just open that up. I'm going to pipe this one into my normals. Now, this isn't necessarily going to work that way, so what I actually have to do is come down here and do a normal map so that we can convert the space into a tangent. So we'll do in here, then out into normal. Let's go over here and grab my normals. So we'll grab the normal. We'll do file coloring space raw. On the normal map, I'll lower the scale here to, let's say, 0.25. Don't need it that crazy. Let's see here. If I go back to 1, you can see what is happening here. There we go. So my normals are in now. And we can play with this a little bit. So we can come here, base. Under the specular, we have index of refraction. I'll go up to like 2.2. And then under the color, I can just lower this down a little bit so we don't get as much specular. That looks good. Diffuse roughness will go up. This looks good now. Let's get the inside in now. So I'm gonna hit U. Let's go into the wood in, same process. So we're gonna go image, file. Now I gotta go navigate to this. I put it right here. Here it is, base color, same thing. And there we go. You can see it starting to pipe in there. The roughness here as well. Go to specular, specular roughness, and then file, roughness. This one needs to be in raw. I don't care too much about the normals here, but that looks good. So now we have our materials in, and there we go. We actually have that done now. I'll come back here to frame 1. You'll see that it's rendering quite fast, so that took 2 seconds to render. The next thing I want to do is I actually want to get in a camera. So what I'll do is just come here and go to new camera. It creates this in between my Karma render settings and my render ROP. So I actually want to come up here and put this right before. And then under Karma render settings, I'm going to come over here. I'm going to go to 1080 HD. That's where I rendered at this last one. The camera is going to be defaulted to that camera 1. I'm gonna go ahead and just lock this camera and then position it in a way that I like. Let's add in a light here. So I'm just gonna do an environment light. And under the Karma render settings, what I actually wanna do is make sure 1920 by 1080, all this looks good. Under the camera effects, I want to come over here and go to velocity blur. And so let's just go to a frame where it has started shattering, and you'll see that we have plenty of velocity here. If I go a little bit later, you'll see the velocities are showing through. At this point, all you have to do is come down here to the render ROP and then set this to render specific frame range, and I will go to 1 to 72, and then you could render this to disk or render to mplay with whatever settings you decided to choose up here. Let me know what you guys think of this tutorial below. I decided to do this longer form tutorial to show you the full process of doing this wood pillar destruction all the way to render and how I actually got this shot right here. I'm looking forward to making more of these videos here in the near future. Let me know if there are things that you guys want to learn about Houdini or Nuke as well. I'm still doing After Effects videos on this channel, but I'm really diving deep into Houdini and Nuke at this time. If this is your first time to the channel, please subscribe to the channel, hit that bell icon. Be sure to check out my Twitter and all my other social media handles, and including my website. Sign up for my newsletter so that you know when new videos and new content is being released. And until next time, always be creative.